Meet Jake. Jake owns his own outdoor wood-fired pizza oven where he produces real Naples-style pizza. Jake has hired us to perform some managerial economic consulting. We will perform this consulting over the next several videos. In this video, we will explore his production technology. A production function describes how Jake combines capital and labor to create his output, pizza. Capital and labor are economic resources, also called factors of production or inputs. Capital is defined as the tools, machinery, plants, and equipment that are used in the production process. The pizza oven and other tools like pans or pizza cutters are examples of capital. We will denote capital with the letter K, labor as L, and the output Q. The output is also called the total product. In this video, we will analyze Jake's pizza production in the microeconomic short run. The short run is a period of time so brief that at least one factor of production cannot be varied. We assume it is easier for Jake to vary the amount of labor by hiring or firing workers than it is to vary the amount of capital, like the pizza ovens, that he uses. So for Jake, in the short run, if he wants to change the number of pizzas he is making, the time is too brief to change the number of pizza ovens he has, but he is able to hire or fire workers. In the microeconomic long run, the time period is long enough that all inputs can be varied. In the long run, Jake can look at the demand for pizzas and the prices of all the inputs and choose the most profitable number of ovens and hire the most profitable number of workers. In this video, Jake is in the short run, using just one pizza oven. The amount of time that differentiates the short run from the long run varies by industry. For Jake, if he decides he needs more pizza ovens, it may take him a couple of months to plan and execute the change in capital. For a manufacturing company like Boeing, this period of time differentiating the short run and the long run is much longer. This is a picture of Boeing's manufacturing plant in Everett, Washington. It is the biggest building in the world. It is over 472 million cubic feet. The plant contains 26 overhead cranes that travel on 39 miles of ceiling track, moving parts throughout the plant. In the long run, everything, including the size of its manufacturing plant, is variable. In the short run, if Boeing wants to produce more airplanes, it can hire additional workers, and it can even purchase some types of additional capital. However, to vary the size of its manufacturing plant may take many years of planning and building. So in the short run, at least one input is fixed. In the long run, all inputs can be varied. As a first step in our consulting project, we have decided to put some data together to describe Jake's production process. In this table, again, L stands for labor, which means the number of workers Jake has hired. Q is the quantity of margarita pizzas produced. If there are no workers working with the pizza oven, 0 pizzas are produced. If Jake works by himself, he can produce 5 pizzas each hour. So when L equals 1, Q equals 5. When Jake hires a second worker to work with him, the output increases from 5 pizzas an hour to 11. We assume that each additional worker he hires is just as skilled and productive as he is. The marginal product of labor is a powerful tool to help us analyze Jake's production decisions. The marginal product of labor is the additional output from hiring one additional worker, holding all else constant. It is given by the change in output over the change in labor. Here we are holding the number of pizza ovens and the type of pizza ovens constant. When just one worker was employed, the marginal product of labor was 5 pizzas. The marginal product of labor for the second worker is 6. This means that hiring the second worker increases the output by 6. Why does the marginal product increase with the second worker despite the fact that both workers are identical? There must be some synergy between the two workers. When Jake works by himself, he has to do every task himself. But when he hires a second worker to work with him, they can now divide up tasks in a way that makes it so that the output more than doubles with the second worker. Perhaps Jake focuses on throwing and shaping the dough and building the pizza, while the second worker focuses on cooking the pizzas in the oven and serving customers. Now suppose Jake hires a third worker that is just as productive as himself. When the third worker is hired, the total number of pizzas made each hour increases to 16 pizzas. What is the marginal product of the third worker? Please take a minute and solve this problem. Hiring the third worker increases the output from 11 to 16, while the number of workers increase from 2 to 3. The change in output over the change in labor is 5. That is, the additional output from hiring the third worker was 5. Now suppose that when a fourth worker is hired, the marginal product of labor is 4. What will be the total product with 4 workers? Please take a minute and solve this problem. If the marginal product of labor with the fourth worker is 4, this implies that output increased by 4 when the fourth worker was hired. So output increases from 16 to 20. You can see that, once again, the marginal product of labor has decreased. When the marginal product begins declining, we call this diminishing marginal returns. The law of diminishing returns means that as more of an input like labor is added, eventually the marginal product will begin to diminish. Notice that the output is still going up, but it is now going up by less. As long as the marginal product is positive, diminishing returns implies that the output is increasing at a decreasing rate. The reason that the marginal product of labor diminishes is because we are holding all other inputs constant. In this example, we are holding capital constant. Again, in this example, the pizza oven is an example of capital. So are any pans, pizza cutters, or spatulas. As we add more labor without increasing the amount of capital, the workers must all share the existing pizza oven and other tools. Eventually, things may even become crowded, or bottlenecks may occur. The average product of labor can be used to measure the average productivity of the workers hired. It is the output per worker. What is the average product of labor when 4 workers are hired? Please solve this problem. Plugging the output and number of workers when labor equals 4 into the equation of average product, we get 5. This means that when 4 workers are employed, each worker produces 5 pizza on average each hour. Here we have calculated the average product of labor for the other units of labor too. If when a 5th worker is hired, the average product of labor is 4.6, what is the total output? You can find this by plugging the values you have into the average product of labor formula and solving. Take a minute and solve this problem. The average product of labor equation implies that output is equal to the average product of labor times labor. So when 5 workers are hired, the total output is 23. Here is a table entirely filled out for all 6 workers. If you study the table, you'll see that any time that the marginal product of labor is greater than the average product of labor, the average product of labor increases compared to its previous value. Also, any time that the marginal product of labor is less than the average product of labor, the average product of labor decreases compared to its previous value. The top graph illustrates the total product curve. It shows how total output changes as the amount of labor employed changes. When looking at this graph, what economic concept does the slope illustrate? If you said marginal product, you are correct. Recall that the marginal product of labor is the change in output over the change in labor. That is the same thing as the rise over the run in the total product curve illustrated in the top graph. The slope of the total product curve is marginal product. The graph on the bottom illustrates the marginal product. You can see that when the slope of the total product curve increases, the marginal product increases. And when the slope of the total product curve decreases, the marginal product decreases. The red line marks the point where the slope of the total product curve is at its max. Since the slope of the total product curve is the same as the marginal product curve hits its max at this point. Since the slope of the total product curve increases from 0 units of labor to the point of the red line, the marginal product of labor increases from 0 units of labor to the point of the red line. After the red line, the slope of the total product curve starts going down. This implies that output is increasing at a decreasing rate. In other words, the marginal product of labor begins diminishing. So diminishing marginal returns begins after the red line. At the green line, the total product curve reaches its maximum. At this point, the slope of the total product curve is 0. Thus, at this point indicated by the green line, the marginal product is 0. After the green line, the marginal product of labor is negative, so output is actually decreasing at this point. The blue curve represents the average product of labor. Once again, you can see that when the marginal product of labor is greater than the average product of labor is increasing. When the marginal product of labor is less than the average product of labor, the average product of labor is decreasing. When they are equal to each other, the average product of labor is at its maximum. To understand this relationship, consider an average product that you are already very familiar with, your GPA or grade point average. If your output is grade points, your GPA is the average product. Your marginal grade is the additional grade that you get in this class. Marginal in economics means additional. Suppose you have a 3.0 GPA and you receive a C in this class. This would imply that your marginal grade, that is the additional grade, is less than your average product, or in other words, GPA. Since the margin is less than the average, your GPA will decrease. Now let's talk about a much more likely scenario. Suppose you get an A in this class. Now your marginal grade is greater than the average. Thus, the grade you get in this class will pull your GPA up. Hey, great job!